This time we are going to solve the general polynomial and polynomial-like equations by factoring. Zero factor property is always the strategy to solve this kind of equations after factoring completely. For number 2, solve the following polynomial equations by factoring. In part A, we have 2 times y to the third plus 2 times y to the second equals 4 times y. We have the equation and the highest power is 3. This is the cubic equation. To solve the polynomial equation, we always move all terms together and leave the other side to be 0. So we have 2y to the third plus 2 times y to the second minus 4 times y equals 0. And then we're going to solve for y as we see all terms containing y. So the GCF, or the greatest common factor, is y, and also the value 2, as 2, 2, and negative 4, the common factor would be 2. So we factor the 2y out of each term. Then we get the remaining factor of the first term as y to the second term as y to the first power, and then the last term as negative 2, then equals 0. Next, these 3 terms we can factor further by using the technique that we have been doing. So y squared plus y minus 2, the leading coefficient is 1, so we have y and y here. And then think about the 2 numbers that multiply to get negative 2, but the sum is positive 1. The product is negative, but the sum is positive. So both of them gonna be opposite inside, one positive, one negative. If the sum is positive inside, so then the larger quantity will have the same sign as the sum. That means we have positive 2 times negative 1 to get negative 2, but the sum is positive 1. Back to the problem. So we have y minus 1 times y plus 2 equals 0. And then we can treat the first factor here as y minus 0. So 2 times y minus 0 times y minus 1 times y plus 2 equals 0. And then we use the zero factor property to treat each one to be 0. That means the first we have y equals 0. The second one we have y equals 1. And the last factor we have y equals negative 2 as solutions of this equation. For the next polynomial equation, we have x to the third plus 4x squared minus 64x minus 256 equals 0. So this problem, we have 4 terms. We are going to factor by grouping. We're going to group the first 2 and the last 2 together. Quantity x to the third plus 4x to the second plus negative 64x minus 256 equals 0. And then find the greatest common factor of each group. The first one, we have the greatest common factor as x to the second. And then in the parentheses, we have the remaining factor as x plus 4. And the second group, the greatest common factor would be negative 64. And then leave the remaining factor as x plus 4 equals 0. We have the common quantity x plus 4. So we rewrite it as a common factor and then gather the rest of the factor into the group symbol. So to get x squared minus 64 equals 0. As you see, x squared minus 64, this one is the difference of 2 squared. So as one of the special product, so a minus b times a plus b equals a squared minus b squared. This one, we can see this as x squared minus 64 as x squared minus quantity 8 squared. Therefore, our A is x, our B is the value 8. Then we can factor this to be x minus 8 times x plus 8. And together with the coefficient factor there, that's x plus 4 equals 0. Then we use the zero factor property. So each factor equals 0 to give us the solution x equals negative 4 for the first one, x equals positive 8 for the second one, and x equals negative 8 for the last one. So we have 3 solutions for this polynomial equation. For example C, we have 8 times y to the third plus 27 equals 0. 8 times y to the third plus 27, because the power 3, think about the sum of the two cubes. The value 8 is 2 to the third power. 27 is 3 to the third power. So we can rewrite this as 2 to the third times y to the third plus 3 to the third power. So all of them have the power 3. But the first term, we can write those two factors as 2 times y raised to the power 3 plus the quantity 3 to the power 3 for the second term. So then we can use the formula for the sum of the two cubes as a to the third plus b to the third equals a plus b multiplied by a squared minus a times b plus b to the second power, or a squared. In this case, the a is 2y and the b is the value 3. Factor completely to get 2y plus 3 multiplied by the quantity 2y to the second power minus 2y times 3 plus the quantity 3 squared by following the formula of the sum of two cubes. And then the other side is 0. You simplify a little bit more for the second group to get 4 times y squared minus 6 times y. And then plus 3 squared is 9 equals 0. For the factor 4y squared minus 6y plus 9, we're going to use the quadratic formula. To simplify it. So in this case, we have a equals 4, b equals negative 6, and c equals 9. The quadratic formula is y equals negative b plus minus square root of b squared minus 4 times a times c, all divided by 2 times a. And for this expression, we have negative times b, which is negative times negative 6, plus minus square root of negative 6 quantity squared minus 4 times a, which is 4, and then the c is 9, all divided by 2 times a, which is 2 times 4. And then we get the number 6 plus minus square root. This one you get 36 minus 144 in the square root, which is square root of 109 with a negative inside. So with the negative real number under the root, we get the I times square root of 108 or 108. So we have I here and then 108 all divided by 8. And then the 108 is 6 times 2, that is 12, 12 times 9. Or we can rewrite it as 4 times 9 times 3. because if we look at the square numbers, we can take the square root and simplify it more. So we got the square number 4, number 9, number 3. So that means this becomes 6 plus minus I times square root of 4, square root of 9, that becomes 2 times 3, and then leave the radical 3 in there, or divided by 8, or write it out as 6 over 8 plus minus 6 over 8 square root 3 times I. 6 over 8 is 3 over 4. So simplify one more to get the conjugate complex solution. And also the first factor here, remember, we have to keep it as another solution. So then we have 2y equals negative 3 or y equals negative 3 over 2. So we get 3 solutions for this equation. For this example, we have the equation in the form of x to the power 7 over 3 plus x to the power 4 over 3 minus 2 times x to the power 1 over 3 equals 0. We would say this is the polynomial-like equation. The power x to the 1/3, x to the power 4/3, and x to the power 7/3, the greatest common factor is x to the power of the lowest, which is x to the 1/3. So that means 4 over 3 is 1 over 3 plus 3 over 3. 7 over 3 is 1 over 3 plus 6 over 3. That would be easier for us to factor before we solve for x for this problem. So we're going to factor the greatest common factor, which is x to the power 1/3. And then the remaining factor of the first term will be x to the power 6 over 3 plus x to the power 3 over 3 for the second term minus 2 equals 0. 6 over 3 is 2. So then the equation becomes x to the power 1/3 times x to the second plus x minus 2 equals 0. And then the trinomial, or the 3 terms in the parentheses here, can be factored more. Same strategy. The number negative 2 is the product of 2 numbers that the sum equals positive 1 as a middle term. So negative 2, one is negative side, the other is positive inside. The sum is positive. That means the larger quantity would have the same sign as the sum. So that means positive 2 times negative 1. Then we factor this to be x minus 1 times x plus 2 equals 0. And multiply by x to the power 1/3. Now we get 3 factors. Use the 0 factor property to solve for x. So for x to the 1/3 equals 0. X minus 1 equals 0, and x plus 2 equals 0. For the x minus 1 equals 0, we get x equals 1. X plus 2 equals 0, get x equals negative 2. For x to the power, so we're going to raise to the power 3 both sides to make x raised to the power 1. But 0 to the third power is still 0. Now we get 3 solutions for this problem.